Hello, student. This is presentation 4, Sustainable Materials Assessment. Hello. You may be asked to participate in a waste audit or assessment in the future. Conditions and project might be quite similar to this picture of a college campus waste sort, but do you identify any issues? First, check out the student standing on the bin outlined in yellow. This is dangerous and should never be attempted. Now look at the student bent and picking through trash. Her hair should be tucked away, and all of the students need basic safety equipment. We call that personal protective equipment, or PPE. You don't know what you're going to find in trash or even recyclables. There could be COVID lurking, or syringes, or other nasties. Finally, I thought it was interesting what we see outlined in red. Liquor bottles, laugh out loud. I used to joke with my sorters that they would receive $5 an hour and all you could eat or drink, as the case may be. What exactly is the importance of measurement? Well, first of all, sustainable materials management is a systemic approach to using and reusing materials more productively over their entire life cycles. So you're going to have to know things about life cycles. You're going to have to know about different approaches and how you can use and reuse materials more productively. So if you don't know, if you don't study, you can't figure out what it is that needs to be fixed, what needs to be changed, what the various impacts are. It's just really difficult unless you actually measure things. You can't fix what you don't know. So by looking at a product's life cycle, we can find new opportunities to reduce environmental impacts, conserve resources, and reduce costs. And we can look in aggregate or by individual product. We can look upstream, downstream. And so through metrics and analytics, complex systems can be simplified to more easily understood terms, leading to viable solutions. On this particular slide, we have 4 reasons to assess. One, it could be a residential type assessment that's employed in studies to determine participation and set-out rates. And there's a difference between participation and set-out rate. Someone might participate, 2 similar homes might participate, but one sets out their recyclables once a month and the other sets out every week. So you need to know what those differences might be. There's contamination levels. I know some cities have their recyclables set out by their residents, and they may have contamination levels as high as 40% or more. And then others might only be 10%. And you got to know what these different types of differences and why they exist. And there can be changes in material streams. Um, Over time, and we'll see this a little bit later in this particular presentation, waste changes over time. We have a lot more packaging today than we ever have had. There can be commercial assessment, that's at-source generation analysis, sort of end-of-the-pipe composition of materials and recycling and trash bins. We call that like dumpster diving. There can be we could sample discrete loads or do a comprehensive review of all materials generated, of a single source. There are macro scale assessments. We can do things like by sector, all the residences, all the businesses. They can be jurisdictional, like the entire city or maybe a multiple of cities. They can be industry wide, like all the companies in an area that are warehouses, for example, because they have like very similar waste streams. And it can be regional. It could be county-wide or it could be statewide. The state of California every year does a statewide assessment of its trash levels. It could be national, and the United States as a whole hasn't done a whole lot in the past few years, but in the past it's done some major analyses of the entire waste stream by sector, by industry, and so forth. And it could even be international. And for example, assessing plastics around the world, where the leakages that occur in systems. And finally, we take a look at forensic and program assessment. These are non-material assessments. We're looking at other types of things like programs and contract compliance. There's typical approaches and purposes to a lot of these types of assessments. One assumption that's sort of a fallacy, isn't always true, and that's what I put up here. The first assumption: this is how always, waste is going to be, and no, that's not the case. It does change over time. And so when we take a look at the different levels of waste assessment, it could be national, it could be state, local government, and specific waste assessments or audits. And a lot of times national assessments are done to determine quantity and composition of post-collected solid waste on a national basis. And usually surveys are taken at landfills and incinerator coupled with surveys of recyclers to determine like gross quantity and composition of solid waste. And typically it comes up with a typical or an average waste emission factor. Statewide assessments, usually to determine quantity and composition of MSW on a statewide basis, again, often at landfills and incinerators. And the idea here is like, how are we doing as a state? Because in the United States, it's not a national type program. We have statewide programs. Every state is given an option to develop its own program. It can be more stringent, but it cannot be less than, you might say, what the requirements are at the national level. To date, about 17 of the 50 states have completed a statewide assessment. There are local government assessments of waste in which we characterize local waste quantity and composition to determine diversion rate, disposal needs, and potential material availability for local community-wide programs. And historically, a lot of cities have assessed their waste for volume, for landfill design, and or call it your heating value, calorific value for energy, like for incineration. And then you have specific waste assessments or audits, and these are characterizing solid waste source by source. At source waste assessment. This is what I really like and what I have spent a lot of time and effort working on is sort of, I call it the best practices facility assessment. And so you're looking at pre-cycling and recycling elements, and you're really getting, to understand the business and determine how and why it generates waste and be able to design things both upstream, midstream, and downstream, as we show this on this chart here. This is usually based on a systemic model of production, and in order to really do this type of analysis, you got to have a pre-audit contact. You got to get to know the business, get information about the business, study it. So before you actually go into the business, you're going to know what you're going to be looking at and looking for. You're going to start in stream within a facility, or you might say midstream. In other words, like what's generated within the facility itself. You would determine how wasting occurs, and then follow it downstream to the disposal bins. And then you can determine your logical intervention points. What could you do, further up the ladder so that if you can focus on when waste is sort of like unique or consistent before it gets all jumbled into a bin. Well, once it gets all placed into a bin, it's very hard to get that and more costly to separate it. But if you go upstream in a facility and you can take a look at where it's being generated, you can understand why and how it's being generated and determine if there are technical or non-technical aspects as to why that is occurring, and be able to intervene and develop a program that will very cost effectively develop some solution. And often savings in one area can pay for extra costs in another with a net benefit. This often happens with like energy and water and waste and air, that sometimes one program can be piggybacked on another very efficient or effective program. So typically what we take a look at is how can we make changes in raw materials and packaging. So these are inputs into the facility And then midstream, we take a look at technological and economical changes, good operating and maintenance practices, and also on-site reuse and recycling. Typically, most audits, which are done in sort of a fragmented manner, they may take a look at the energy, some may take a look at water, some are focused on waste, and some are on air audits. But an at-source best practices facility assessment really takes a look at all these different things. So it's not just one snapshot of some component, and that's where you can find the opportunities, for piggybacking one program with another. And then ultimately, you take a look at downstream, what comes out of the facility. How can you make changes in your product and packaging and toxics reduction so that it's a better product for your customer? And that's where the life cycle costs come in very, very succinctly. And also with the changes in raw materials and packaging upstream, that's important because that can give you an opportunity in your facility to target something that ends up being kind of costly and becomes a very difficult issue to solve within your facility. If you can go upstream to your supplier and work with them to change how they deliver materials to you. A famous story, for example, that I use quite a bit is at Ricoh Electronics. They used to have a lot of cardboard boxes come in, and they would recycle all the cardboard boxes, but it took time and effort, and they had to cut the boxes apart, and sometimes people would get injured. They cut their fingers and stuff. And they took a look at that and said, why are we doing this? Let's work with the supplier. And they came up with a program in which the boxes were designed to be returned, and they could just be pulled apart. They were constructed boxes, in essence, cardboard with some plastic binding around it so that they kind of snapped apart. They would stack it and they would send it back. And that was good for the supplier because now they had their boxes coming back and they could create them again, fill them up again, send them out, and then they would get returned. And it was a very easy process for Ricoh because they could pull them apart very easy, stack them, and bind them up in some shrink wrap or something, and send it back. And they eliminated a lot of injuries from that. Now, if you're familiar with True Zero Waste certification system that helps facilities quantify their performance and find additional ways to improve their progress towards zero waste. True Advisors, that's part of now the Green Building Council. And at one time it was the U.S. Zero Waste Business Council, but that combined with the U.S. GBC and to create this True Zero Waste certification. And they very much take this more of a systemic approach, and in fact use your professor's approach to doing at-source evaluation. So their scorecard is they begin with like a simple certification. You kind of like get 31 to 37 points out of the total of 81. You want to be silver level, you got to achieve at least 38. Gold, you got to get at least 46. Platinum, you got to have at least 64. And here's all the different categories and the points. So you can see it's a lot more than just taking a look at what's in the trash. It's like, are they redesigning? Are they composting? Are they doing closed loop systems, taking things back? Ricoh, for example, changed their marketing and economic model from selling to leasing. Okay, so that creates a closed loop system. How much innovation? What kind of leadership? What kind of training education goes on? How much toxics are being prevented? How do they report? Do they use environmentally preferable purchasing practices? So all these things come in, and if you look at this scorecard, you'll see that diversion, which you think for a lot of folks, that's the ultimate thing that we got to do. It only gets 5 out of the 81 points. So you got to do a lot of things to get to the right levels that you want. And so being a platinum level is important for a lot of different companies. Some of the businesses that have true certifications, and true little advertisement here: rethink the resource life cycle, demonstrate to the world what you're doing to minimize your waste output. And that's one of the reasons that people do get certified, is like they can brag about it and either attract more investment, attract customers, demonstrate to neighborhoods and to the business community how well they do. But Whole Foods Market, they did 20 stores in Southern California. Sierra Nevada Brewing Company, the first facility that was certified by the USZWBC in 2013 with a 99.8% waste diversion. But again, that was only 5 points out of the total amount. And so these are all a variety of different companies. And as you can see, it's a wide variety of different types of businesses and industries, but the focus is on industry. True is not for communities. It's not for you might say the like neighborhoods or residential. It's pretty much specifically focused on individual businesses. And there are, in the United States, about 37 million businesses. Most of them, of course, are small businesses. So that's their market, is 37 million businesses that exist in the United States. There's a couple of ways that you can assess solids, your residues, your residuals. You can go dumpster dive, and you can dumpster dive with hands-on, or you can be more visual. But the physical is very precise. You're going to know exactly what you're dealing with and handling, but it's costly, it's kind of disgusting. It yields quantitative and certifiable results. LEED certification requires a physical sort. Now that may change a bit with the because of the true zero waste advisors that do visual audits based on my protocol. Visual is accurate, it's less costly and clean. That yields qualitative results, not so much quantitative, because again, precision and accuracy, two different things, but they're very important to understand. You can know exactly down to you might say, to the ounce, exactly how much is in a load of material. But does that give you better information than just to visualize and see that a load of material is almost 80% paper? Do you have to measure every single piece of paper to confirm that it's 80%? No, I just don't think so. I don't like handling this type of material, and I never ever recommend any students to go out and do any type of physical sort. It is indeed less safe. So we're going to take a look at dumpster diving, the physical assessment here for a moment. Please don't, like in that TV show there, please don't get into the trash can. Okay. Aha, so this is what you see. This is waste characterization before you begin sorting. And like I say, it's kind of disgusting. There's a lot of different bags. There's all kinds of stuff in there. I can see that when I'm just looking at this, that there's going to be a lot of paper and there's going to be a lot of plastic. In fact, most people put their trash into plastic bags. Okay. Now, this is an important point because almost every facility, every building, about 8 to 10% of all their trash is not people what they trashed. It's the bags that they put their trash in or their recyclables in. So we inadvertently create another 8 to 10% of material to be thrown away just by bagging everything. But this is generally what you're going to see if you're going to do some kind of physical sorting. All right, once you get through the sorting thing, you can break it down. You can see there's some food, there's paper boxes, there's plastic and other types of plastic, a lot of plastic, which is the case. A lot of food, a lot of plastic, a lot of paper. And for food and paper, You know, it's like about 65% of all of our waste in urban areas is uh, fiber and organics. Now, the visual assessment is an eyeball estimation methodology where individuals can observe, document, and identify the characteristics of discarded materials or products for the purpose of making a value judgment. And qualitative observations are made of specific material characteristics. These are the things that I do a lot of. I want to know like the generation characteristics, the origin, both pre and post collection. Pre-collection enables me to intervene upstream. Post-collection, I'm just whatever the hand you're dealt with. That's what you got to deal with. I can take a look at load moisture content for perhaps wet or dry routing, and we'll talk a little bit about that in a minute. Material recoverability, 0 to 100%. And you can do this by clean dozen categories. Clean dozen basically implies that materials or wastes are composed of resources, and you can characterize it by 12 broad categories. Things like fiber, inert material, chemicals, metal, glass, things of that nature, polymers. You can take a look at how organic or inorganic the waste is. Is it elemental or whole product? You can identify the vehicles that were used to deliver materials, and you can then also do upstream assessment of materials. And I'll describe how some of these things can be utilized when you go to a business and you can examine and you can see for yourself. It's like when waste is picked up and or at the source, everybody puts it into a common container, and at that point, everything is mixed. And then that material gets picked up by a truck that usually visits a lot of different places, and it keeps mixing things, mixing things, mixing things, and by the time it gets to the place where it's going to dump it off, let's say like a dirty MRF or something, then it's really mixed, and there's a lot of cross contamination. It's just garbage. So that's what you can see when you go out and do some of these visual assessments. Visual estimation takes training. It's not all that easy. It can be a little bit difficult. You can see, just looking at the materials here, you gotta have a sort of a little methodology in terms of pinpointing, what it is, when you're doing some counting, because that's basically what you're trying to do is count and try to figure it out. Now, understand that you can get accurate weights, like what this truck that's dumping this particular load has a weight, and it's a tare weight and also which is the empty weight, and the full weight, which includes all the contents. And if you know the weight and you can break down into relative, you might say percentages based on some counting, from visual estimation, you can figure out like how much paper, how much plastic, how much bottles, how much, yada, yada, yada. And in a ton of material, you can figure out the relative weight just by this volumetric type of approach, because material has specific density. And so if you know how much paper is in a load, and you count like 9 out of every 10 materials are paper, it may be that the paper doesn't represent 90% of the weight. It's 90% of the volume. Plastic's the same way. It might be 60% of the volume, but by weight it may only be 20% because of its density. So you got to be careful in that respect. So it's not like a really easy thing to do. It can be a little bit difficult, to properly make your quantification. Other times it can be a little bit easier. I mean, you can see here it's like there's metal, there's paper, there's wood, there's tires, a lot of metal here, and metal drums, and looks like a composite desk. I mean, there's a lot of different things here, but you can kind of break this down, and again, using densities, you can come up with a pretty good idea because you're going to know what the weight is overall, and so you can begin to break that down. There's three things that we can do for audits of compliance. We can assure compliance with laws, rules, or standards. We can assure compliance with contract specs, or we can examine the efficiency and effectiveness of a system. So audits can be done for compliance purposes. For example, contamination levels in curbside collection, how much recyclables are left in the trash, the presence of toxic components, how well somebody is doing with a contract for, let's say, composting or efficiency and effectiveness of sorting. And obviously, high grading, how well you can grade materials into the different subcomponents, like paper into newspaper. Well, we don't really have newspaper anymore, but newsprint and cardboard and office paper and things of that nature, and each one of them has a different value. And if you can grade it into all of those, that's much better value, because if you just give somebody all those things jumbled together, you get even a lower value because it's called mixed paper. And so mixed paper is less than newsprint. So if you can sort it into newsprint, you can sort into cardboard, you can sort into office paper, you're going to get a lot higher value. The whole thing is you don't want to leave money on the table. There's also forensic auditing. I've done some of that. It's an investigative practice used to identify and quantify service and fee anomalies and inconsistencies in municipal waste and recycling, collection, processing, and disposal systems. Now, what does forensic mean? It means suitable for use in a court of law. It actually can resolve actual or anticipated disputes or litigation. It can also provide for financial recovery in communities from perhaps fraudulent or inappropriate activities. Sometimes, like if people can get away with something, they will. And so a forensic audit can determine if someone is, doing the right thing. I'll give you an example in a moment. It's helpful in negotiation processes for municipal related contract and franchising. And usually successful audits follow the waste and use rules of thumb, like the general density of trash, and how does that figure with the amount of material that's actually being collected. And there's a lot of ways that you can do auditing projects, and in fact I've done some in which I've been able to earn for my customers millions of dollars, and that they were able to recover. So in one case, the city of let's say the city of Corona, for example, hired me to take a look at their waste system and come up with rate structure, to charge people, because they're in that particular city they had a enterprise fund. And you can ask me what an enterprise fund is later, but often dedicated monies for a particular purpose at a city. And in any event, the city was in the red on its waste services. Even though they contracted it, the commercial and residential, they actually were collecting the money and from customers, and then paying the hauler for the service. But what the hauler was reporting wasn't very accurate, and I discovered that by doing some forensic auditing. And I came back and said, well, what they're reporting is not is inconsistent with my rules of thumb: how much density, how many routes and trucks and capacities and things of that nature. And I estimated that they were underreporting, like about by a third. And it got a little bit contentious with the hauler, but they did go back and they quote unquote sharpened their pencils, and they came back and they they came back with, oh, mea culpa, we actually underreported by almost 50%. So things like that, and it was during a negotiation process. They wanted to have an extension on their contract, and the city wanted a rate structure that was going to be consistent. And so I was able to, fit both of those things together. And actually the city got like $35 million in terms of a recovered value. The hauler paid the city that amount of money without raising rates. Rates stayed the same, but the amount of money that the city was able to receive in terms of a franchise fee went like from $2 per household, or excuse me, about 2% per household to about 12.5% per household. That was their franchise fee. And they were able to get this money. It saved their bacon, and oh my gosh, so many different programs at the city without raising rates. So this is what a forensic audit can do. I'll talk a little bit about another assessment called WARM, the Waste Reduction Model. And EPA created the Waste Reduction Model, WARM, to help solid waste planners and organizations track and voluntarily report greenhouse gas emissions reductions from several different waste management practices. And WARM calculates and totals GHG emissions of baseline and alternative waste management practices like source reduction, recycling, anaerobic digestion, combustion, composting, and landfilling. And the model calculates emissions across a wide range of material types commonly found in municipal solid waste. WARM is currently available as a tool based on a database developed in Open Lifecycle Assessment, OpenLCA software, with versions available for both Windows and Macintosh users, Apple users. WARM is also available as a downloadable Microsoft Excel spreadsheet, and many agencies use this to calculate actions and activities of, let's say, grantees, folks that want to get money from a grant program, and they need to show how effective their program is, for whatever that program might be, like let's say a reuse program in the state of California, or composting or recycling program. And you got to have something to compare all the different projects. How do they all compare based on how much offset that they can create for GHG accounting purposes? So this is all done in metric tons of carbon dioxide equivalent. That's metric ton CO2 to E. And you look at the alternative between landfilling versus recycling, for example. And the example in this picture here is the life cycle GHG accounting perspective of paper. If you just threw paper away into the landfill, it's going to release methane, CH4. However, if you go through the entire process from extraction, pulping, transportation, usage, are you recovering it, and then are you recycling it? And what do you do with the recycled content? If you can spend more time or more material, extract more material, you're going to find a net benefit life cycle perspective for the industry as a whole. So the WARM, like the GHG savings, are calculated by comparing the emissions associated with managing materials under an alternative scenario with the emissions associated with the user's baseline scenario. In other words, the current practices. It's not like just simply multiplying the quantity of materials managed by an emission factor. For example, the GHG savings of recycling 1 ton of aluminum cans instead of landfilling them would be calculated as follows. You would take the 1 short ton times, the savings that would accrue to that for recycling, minus the short ton that you used to be throwing it away, and that would give you some net. And you can see that it's actually a little bit bigger than than if it was just a calculation based on multiplying the quantity. So when the results in warm show a negative value, and here in our example it says minus 9.13 metric tons carbon dioxide equivalent, this indicates that managing that material using the selected management practice results in avoided GHG emissions or energy from a life cycle perspective. And here it's pretty good. Okay. Now, although emission estimates provided by WARM are intended to support voluntary GHG measurement and reporting initiative, WARM is intended as a planning tool and not an accounting tool. So there are other tools that are available which are specifically used by a lot of different agencies and businesses to actually use for accounting purposes, in terms of like buying carbon offsets and things. Warm is not necessarily to be used in that manner, but it gives people an idea or a means of identifying, you might say, supporting their voluntary initiatives. This is my zero waste toolkit. What's in your toolkit? Well, in this following several slides, I provide a number of advanced tools for use by experienced and trained auditors. Uh, some key things that we'll go through is understanding how solid residuals are generated. You got to understand how they're generated, not just what shows up in the bin, but how are they generated upstream, because that's understanding is everything. It really can help develop a lot of great programs, very efficient and effective programs, and not just cost somebody money, to handle stuff sort of post generation, because like that's always the most expensive. All right, and we'll focus on what I describe as 9 generating source categories. I can break down any business and any community into 9 generating source categories. And that's really helpful, because if you can understand, how things are generated and you can break it down into a very discrete number of characteristics and generating sources, it really makes things a lot simpler. And with that kind of understanding, we can develop routes. Because right now routes are generally just whatever is the easiest, the cheapest way. And isn't that like about a lot of stuff? The cheapest things that we can find? Cheap is often doesn't include all the externalities, so it's really important to understand, you might say, in depth and in detail, a lot of these things so that we can come up with different types of ways that we can collect things, because dry routes versus wet route means there's a lot of water in it, and sometimes that water can be a contaminant for things that are dry. But if you keep things dry, they're easier to sort and separate. And if things are wet, they're probably organic. So there's very important characteristics that can help us in terms of collection. And also we need to understand self-haul. We think of just the haulers being the waste haulers being the only folks handling trash, but that's not the case. There's often a lot of folks that will either haul their own stuff or householders which will take their own stuff. And that's really prevalent in rural communities, less often in cities, but there's still a lot of people that do stuff. And we can talk about that a bit. And then I'll show you how I conducted a citywide waste audit and even show you some of the different containers and stuff. Okay, so what are the 9 generating sources? This is for commercial premises. Although I've told you before that even households can be broken down into a lot of these types of categories. Like I say, kitchen services, the kitchen, that's just like food services. So these 9 sources of generation, I find them either in every business, and I also find them in communities. And communities and businesses can contain all 9 categories, up to 9 categories of generation sources. The wet categories are food services and grounds. That's like vegetation, plant material, landscaping. Housing and hospitality, yes, like apartments and hospitals, hotels, things of that nature. And then there's a line, I put a line there in between wet and dry. Dry is like construction and demolition. Generally, it's like concrete, rock. That's pretty dry. Industrial and services, highly variable. It includes schools and also a lot of businesses, and we'll talk a little bit about that in a minute. Offices, office structures, whether they're single floor or if they're like a high rise of offices, they generate very similar type material, but usually paper, very dry. Retail tends to be dry, clothes, products. You don't want them all wet, so it tends to be very dry. A lot of plastic and stuff, but we'll go through that. Vehicular maintenance, that's like, Pep Boys, things of that nature. And then warehousing and distribution. How do products go you know, um, from the factory, get distributed to, the distribution network, and then they get into people's homes and individual businesses, B2C. All right, the 9 source types and principal materials. For food services, this is mostly restaurants and food markets and food processors and food gardens and bakeries and food trucks. All these types of food services create food scraps and wet organic waste. Grounds are like cemeteries and ball fields, road medians, golf courses, and they produce yard debris and wet organics. But a lot of places may have grounds, landscaping around buildings. So that's what I say, a lot of times you'll find a mixture of these types of things, but in specific, grounds is cemeteries, ball fields, and golf courses and things of that nature. Housing and hospitality, apartments, hotels, motels, and hospitals, and they create very typically residential type waste because they're there to serve people. Construction and demolition, building sites, roads, tear downs, and generally is dry. It's dry inerts, rubble, wood, masonry, wallboard, roofing. Industrial and services is a very big category. It's factories and manufacturing and fabrication, maintenance yards, dry cleaning, operations, schools, and materials depend on type of operation, but they're mostly dry material. For example, like let's say a rubber gasket manufacturer. What do you think they produce? Mostly rubber in terms of their waste. So that's a dry material. 6 is offices, high-rise office buildings, low-rise offices. They produce fiber, like 80, 90% fiber. Electronics and plastic. Retail is like malls and strip centers and brick and mortar stores. Best Buy, maybe Costco, I guess, things of that nature, but a lot of malls and stuff. Sometimes some things could, like a market, supermarket, even though it's retail, it falls under food services because the intent is that there is how much food it might be available in a particular setting. Vehicular maintenance, gas stations, auto dealers, tire and engine repair, they produce lubricants and tires and fiber and plastic. And then finally, warehousing and distribution. Any warehouse and distribution center and all the buildings associated with it, including online retail fulfillment. They're producing plastics and fiber, wood pallets, and metal. So I'm going to give you an example for one type. So my example is warehouse profile, and you can see this is a picture of a typical warehouse. I don't know if you've ever been to a warehouse distribution center. If you just take a look at this, you can see they got pallets, they got boxes, they got plastic wrapping, they got paper, things of that nature. And so what do you think they're going to find in the trash? And it's going to be very similar to that. And the thing is is that every single warehouse distribution center is almost exactly alike. Now, what they're putting in the boxes can vary. If this is an electronics, super warehouse or something, it's going to be a lot of electronics. If it's a food warehouse, it's going to have food, but generally the food is not kept there unless it's breakage and spoilage or something. And so that's a very small amount. It's a minor, I call it a minor, but for major waste types, it's paper and plastic and wood and such. So I need to profile sort of a cross section of this warehousing business. Okay, keep that picture of that warehouse, and I'm going to go through and describe all the different subsources. So principally, this was source number 9, warehouse distribution, but it also includes subsources of all the other 8, at perhaps one time or another. For example, there's always an office. Every warehouse has a business office, and it may only be for one person, or it could be for several people, but there's going to be an office. There's going to be some food service, perhaps like a food area for workers to eat their lunch. Maybe there's an opportunity to make things, to cook stuff of that nature. Or there may be food trucks that come by and service that particular warehouse. But, people take breaks, people got lunch, and maybe this operation operates 24 hours a day. There's going to be three you know, uh, sections of folks, 3 shifts. And as a consequence, there's going to be 3 lunchtimes, for folks. So there's going to be a considerable amount of food. There's a lot of times there's grounds, landscaping, because you see these huge buildings, and a lot of times there's vegetation around it to kind of pretty it up and make it look kind of nice, not so Spartan. Sometimes there can be construction and demolition. Maybe they're doing some remodeling, but this particular example shows no current construction. There's also, of course, the industrial activities, industrial and services, and because that's where people are packaging, unpackaging, because you can see a receiving, people bring packages and they have to break it down into perhaps smaller packages, and then those smaller packages get put into a truck. So the truck, maybe they have vehicular maintenance. Maybe they have their own truck fleet, or at least they got something. Maybe they got a bunch of forklifts and stuff that have to be maintained, on site. And then you have perhaps retail. Sometimes there can be retail, not necessarily, but there can be retail. And then finally, there's housing and hospitality. For example, there's maybe a restroom, and so you're going to have hand towels and things of that nature. So there can be any number of different sources, and all in-house sources contribute to waste that goes into the dumpster. So the dumpsters that are there, are going to receive all the different material. But if you go upstream, you can begin to take a look at these things and break it down so that you're not trying to take what's in the dumpster and recycle it someplace. You know, uh, why when you can go upstream? And I did that for Coca-Cola in Rancho Cucamonga, for example, and I think I'll talk about that a little bit later, but it saved them, a lot of money by going upstream and developing a specific program that dealt with what was being thrown away. Because, oh my gosh, about 90% of everything is either paper, plastic, or wood coming out of a place like this. So the advantages, we've talked about this. You can identify all the reduce, reuse, and recycling options, both on-site and off-site. You can take a look at potential upstream changes. How can you create things so that you have less work to do inside your facility? That means working with your suppliers. You can improve source control of costs while increasing your benefit. And if you have ways that you can package and repackage stuff so that you lessen the amount of breakage and spoilage. You have a potential to reduce personnel costs. I've seen places where they were putting things into a dumpster for, a very large dumpster, a roll-off bin for recycling cardboard. And they had 4 people working on that at any given time. And they were actually climbing inside, jumping up and down on the cardboard to squish it down into the roll-off container. I took a look at that and said, wait a minute, you need to get a baler, or a compactor, because the roll-off container being open top, uncovered, only got like about a ton of cardboard in there, and they had 4 people working on it. And if they went to a baler, all of a sudden it was one person that could work on it, and the bales were worth like $1,000 a bale. So it went from a situation in which uh, basically broke even, and this is not Coca-Cola, but just other example, they were breaking even, and it's probably costing them more in terms of personnel costs. And they went to something which became a revenue center for them. Now, Coca-Cola was a very interesting thing because they were throwing away plastic and paper, cardboard boxes, and wood, and a lot of this stuff is very light, and they might have got like only 50 pounds in a 3 cubic yard container, and they had several of these, and it was costing them $100,000 a year to throw away this stuff. So I took a look at this and understanding all this stuff, I said, let's install yourselves a baler, and you can get a baler for free. I can arrange for either the hauler or the recycler to give you a baler. Well, the hauler said, nah, we don't want to bother. We like what we're doing. Okay, fine. I went to the recycler. The recycler gave them a baler at Coca-Cola. They installed the baler, and they had one person was trained to operate the baler, and then they baled cardboard interlaced with plastic, and they set aside wood for their wood recycler, and so they had paper, plastic recycler, and a wood recycler. They turned the $100,000 cost into a $100,000 revenue center, and their trash went down to like a 3 cubic yard container. It was ridiculous. The hauler was totally upset, complained to the city, but the city said, hey, you had the opportunity to do this and you decided not to do it. So we're sorry. And consequently, they went to some of their other places and instituted very similar programs. But Coca-Cola, I can tell you, was extremely happy. The idea is that there is no way. It's going to come back, and so that's why it's important to develop these type of at-source reviews. So Rancho Cucamonga was the place where I did that particular Coca-Cola review, but it was part of a major citywide assessment. And what are the sources in a typical city? Well, the same as I was mentioning, the 9 different sources. Here we look at all those, every single one of these sources was found in the city of Rancho Cucamonga. And in fact, the distributors, they have a lot of distributors in the city of Rancho Cucamonga. In fact, like they represented over 5% of the city's waste came from like about 10 distributors, or so. It might have been a little bit different than that, but there were a lot of material embedded with the distribution. Mostly cardboard, that's OCC, old corrugated cartons, plastics, and wood. And it's like 90% recyclable. Come on, folks. So by doing that, we have an opportunity to come up with better programming. So this case study of Rancho Cucamonga was really good. I did this back in 2002, and we went to the hauler. There were 2 haulers in the city, and one of them had the MRF that all the city's waste was flow controlled to. In other words, like the city directs both haulers by ordinance to deliver the discards to the designated MRF. So we did that in 2002. It's sited next door in Fontana to Fontana is like right across the freeway from the 15 freeway from Rancho Cucamonga. And the purpose of the audit was to characterize the entire commercial waste stream using visual assessment over 4 seasons for 1 year. And it was going to be supported by way data. And 4 seasons means, like winter, summer, spring, fall, those seasons. And we picked, weeks and a week in each of those seasons to do our visual assessment at a place just like this, just like in the picture. And this is exactly what people were doing, and we had to get in and take a look at the trash and take pictures, and we get the weights of each of the truck, and we watch everything being dropped off on the floor, and we do our visual estimation, technique. But and you'll see this when I talk about stratification, but a lot of times when stuff's coming out of the truck, the back of the truck like this, like a front loader, and I'll describe what the front loaders are, but a lot of times as the trucks go around picking up stuff, they pick up from the different sources. So every time they go to a different source, like let's say an office building, like 80% of the material they pick up at that office building is paper. So they put the paper load into the truck and then push it towards the back of the truck. Then they go to another place, like let's say a golf course, and they pick up a lot of grass clippings and they put that into the truck. What I'm getting at is that you could actually see how the load was constructed. In other words, like how they picked it up. It's almost like, when you drill down into the ground, you get a core, and you can take a look at the core and see it's stratified. Well, the waste comes out like a core, and you can actually see the different types, and I'll show this in a minute. But we needed to find ways to improve diversion from the existing 12% to at least 50% within 1 year. So it was a really, really important thing. And I, was really happy to work with the city because over several years I earned about $1 million from the city of Rancho Cucamonga. So when we took a look at all the different trucks that were coming in and such, and there were hundreds and hundreds of trucks that we took a look at. We got their weights, we got their, the route numbers, and we had a lot of data. There was a lot of data. It took quite a bit of time to sort through this, no pun intended. But we did come up with a lot of good information. Some trucks came in, they were single loads. In other words, like they have a roll-off container, either compactor or uncompacted. They come from a single source. And there was like about maybe 20% of those trucks, or maybe a third of the trucks were like of that nature. And so when you take a look at that, you can see what people are throwing away at a single business. And they're throwing away a lot. And a lot of that stuff coming in was very dry and very recoverable. So that we actually found that 10% of the refuse in the city was coming from 10 generators. So we went back to those generators after this year, and we did site-specific source, source review, source characterization, assessment, and we were able to set up programs that make that trash basically disappear. Like I say, there's like those warehousing distribution centers, Walmart, places like that. We were able to set up baling programs and compactor programs for recycling and actually source reduction as well. And so we were able to make 10% of the refuse in the city disappear almost overnight. And then we also set up wet and dry routing because, my gosh, there was like another, I'd say 40% of the 40 to 50% of the trucks coming in were like commercial loads, front loader loads, and these particular loads could be broken down into wet and dry. And I'll show you that in a minute how they do that. But we were able to go back into the individual routes and figure out how, where they were picking up, and then how we could work with the hauler to to like change their routing and make a particular truck. One truck could pick up, if you had two trucks picking up, a couple of routes, we would dedicate one truck to pick up all the wet sources, and one truck would be dedicated to picking up all the dry sources. And by doing that, my gosh, the recycling rate went up tremendously so that we were achieving 50% recycling the first week. It was amazing. And the haulers were going like, that's pretty amazing. And I also want to note that up to about 30% of the vehicles at the MRF were self-haul loads. And that's something to take a look at too, because now you're taking a look at individuals coming from small businesses, from homes and institutions and places, and they're putting it in their own container, or it could be like some kind of housing contractor, that a roofing contractor, and they're bringing in roofing loads. I remember Mission Tortillas, would bring in their load of stuff from the making of tortillas, and oh my gosh, that stuff would just smell terribly. Not the tortillas, but the stuff that was associated with it, and the slop was brought in and spread on the floor, and it just contaminated everything else, and that's the problem with the dirty MRFs. They just take everything in, and everything gets just so messed up. It's really difficult to do any kind of, really legitimate recycling. In fact, I can tell you, and we'll talk about this further later, but 50%, I would say that dirty MRFs are lucky to get 30% recycling. Clean MRFs, which means they're only taking in commingled loads of recyclables, they'll get 50% or better of recycling. So we've talked about the different types of vehicles that I just mentioned what they were roll-offs and front loaders and things like that. So let's take a look at one of these different types of collection vehicles. And on the left-hand side, at the top, there's a side loader because it loads from the side. It's got an arm, picks up a container, empties it into the hopper behind the cab, and the back part of it is where the material is stored, and there's a compaction mechanism which pushes everything back towards the back of the truck. The front loader picks up from the front. Now this particular front loader, and they all have forks in the front, so these forks can go into a bin, into the side of a bin, and they can lift it up and empty it into its hopper behind the cab, and again push it towards the back of the vehicle, just like in the schematic that I have here. Now, interestingly, the front loader here has a particular can, sort of a dumpster that's affixed to the front that has a self emptying mechanism, so it operates like a little tiny side loader, but it's actually on the front of the truck. So front loaders can be adapted to act like a side loader, but generally they go around, pick up, slide the forks into the bin, and then empty the bin, and then drop the bin back down to the ground level. And then a rear loader. And there used to be mostly rear loaders operated in the country. Now you don't see too many of them, but they're in New York City. They're in a lot of places back east. Mostly side loaders and front loaders are used in a lot of the more modern cities. Older cities tended to have more rear loaders. And then you have, a roll-off truck. Here, this roll-off truck is bringing one of these single bins. So you got like small bins, you got carts, small bins, and you got big bins, roll-off boxes. And that takes a very special truck to load it up, drag it up, and load it onto the back of the truck. So it often comes from one site, takes it, empties it, and brings it back. Now the collection vehicle interior mechanism from the front loader is kind of interesting. You got the container, fork, tilt, dump. That's the forks. Those forks go up. The whole mechanism, tilts up over the cab and into the hopper, which is located behind the cab. And it's sort of the middle of the truck. And then there's a packer blade ejector push-out system, which pushes everything towards the back of the truck. And so at the back of the truck, you got a tailgate, and you also have a mechanism to raise the whole body in order to help empty the container. This is a video of a truck that's a front loader truck. I'll play it. You can see the forks were removed from the truck, and in a lot of places, you got to roll the containers out onto the street. These are huge trucks, and they'll often have up to 10 tons of material in the back of that truck, about 7 tons on average. And I tell you, it's a very skilled position. You've got cars driving through. You really got to make sure there's no people walking around, because people walk behind the truck. You're not bashing into another vehicle. And here, you see, you lift it up, you make sure that the container, which is sloped on the front end, will empty the lids open up automatically. Sometimes they're locked, and if they're locked, you gotta come out and unlock them out of the truck. And usually there's only one person that operates the container truck, or the trash truck. There, see somebody else driving out. So that's collection in action. These drivers make about $100,000 a year or more. Well, as far as a bulk load characteristic, a front loader will normally empty about 40 full 3 cubic yard bins on a route, and 3 cubic yards is the standard for most bins that are collected. There's smaller and there's larger, and I'll show you those in just a bit. The contamination kind of depends on the route. Contents may range from dry loads to wet loads, from totally trash to totally recoverable. I've seen stuff come into a transfer station and it was like, oh my gosh, that's 90% recyclables. What are people doing? Why are they giving it to their trash hauler? And since collected in a compactor, the back of the truck is a compactor, it breaks a lot of things. It contaminates, it smushes it all together. So you get a lot of cross-contamination. And when it's placed in a non-compactor bin, refuse generally has a density of about 115 pounds per cubic yard. I use that fact to help me estimate how much material is actually being picked up out there when I do forensic audits. Then when it's collected, it's compacted up to 500 pounds per cubic yard in the back of this truck. And then when it's landfilled, the refuse is compacted to about 1,200 pounds per cubic yard. They got bulldozers going over the stuff over and over and smushing it down. The importance of compaction is critical for throwing things away, because space costs lots of money. It's very expensive and very difficult to site a landfill. Refuse and recycling routing. Routing is nothing new in the hauling business. Good fleet managers can sketch out solid workable routes using nothing more than a dog-eared street map, calculator, paper and pencils about as quickly as software can, and often far more cheaply too. But we're kind of beyond the days that you just drive up and down the street and pick up whatever's there. We have to deal, and this is something for trash haulers, it can't be trash anymore. They have to be resource haulers. So the kind of ways that we were going about stuff has to change. And just like I changed it in Rancho Cucamonga so that folks were picking stuff on a dry and wet route basis, we can develop a routing that will be consistent with that as well. Now, I show here a typical residential routing. Now, residential is a little bit different than commercial because commercial is based on need, and every business is different. But every house generally is serviced on a once per week basis. And generally, every house has about the same amount of material, uh, plus or minus maybe 50%, but still very similar and very consistent. So you can send a truck up and down the street for residential and be getting your recyclables on one pass, trash on another pass, and finally green waste and organics on a third pass. And generally, like in a community, for example, you might pick up one area Monday, another area Tuesday, another area Wednesday, then Thursday and Friday. And so over 5 days, you could pick up a city. Sometimes some cities want to have pickup all done one day of the week. That means you got to have the equivalent of 5 trucks operating in that city in 1 week. Instead of one driver, in one truck uh, handling a particular area and then going from Monday, Tuesday, Wednesday, Thursday, and Friday, you got to have 5 drivers and 5 trucks all there picking up their assigned area. I'm just simplifying that very much. But like I say, many factors, including zero waste, make manual routing a thing of the past. Pretty much all routing today is computed using GPS software and algorithms. And in fact, you can see everything being picked up even online, real time. And a lot of cities are demanding that everything be recorded. All right, so the typical route, when the truck goes up and down the street, just picks up anything and whatever, as the bins are out there, it'll pick it up and it'll go through and pick up maybe 40 different bins. Um, So routing is done for fast and efficient collection only. There's no distinction among the sources. It commingles wet and dry materials. And this causes problems in terms of recovery because you got this cross-contamination. And like I said before, when I see the stuff that comes into a transfer station, to a MRF, I see things as they come in, as they picked it up. For example, the first thing they picked up was maybe a cardboard retailer, some kind of retailer. They picked up a lot of cardboard. And then they went to a construction site and there's a lot of wood. And then they went to apartments and picked up a whole lot of apartment bins. And you can see it's like a mixture of waste. And then it went to to a restaurant where it picked up a lot of food waste. And then it went back to a distribution center where it picked up a lot of cardboard, and then finally ended up at a golf course where it picked up a lot of green waste. And you can actually see it. And sometimes I was at the transfer station, and my gosh, the whole middle of the load was nothing but cardboard. And I mentioned it to the floor supervisor, and the supervisor would call over a bulldozer, and they go right through the middle of the load and move that cardboard right out of the load, because they didn't see it, or they were happy that I mentioned it because that's money. Again, everything that the hauler picks up, they're charging for. And if they can turn it around and make money from it with a minimal amount of processing and handling, now that's money in the bank. So all that is typical, for commercial refuse. All right, so let's say we've rerouted now, and we got the dry route and the wet route. This is our dry route. It's mostly recoverable dry material. Low to moderate contamination. It's easy to sort, has a higher market value, and it's light separation with the same truck. And there, I picked up a retailer, got a lot of waste paper. They went to the construction site and picked up the wood. They went to the distribution center and picked up the cardboard. They went to an office complex and picked up a lot of dry waste paper. And they ended up at a bookstore and picked up a lot of cardboard. Cardboard waste, laden waste, I should say. It's not all cardboard. Somebody, if they had all cardboard, would probably arrange for somebody to come and recycle it. But that's not always the case. But the point is that it's mostly dry, recoverable material, like sometimes 90%. And so now for the hauler, you're still being paid for the same service, but you're going to get a much higher level of recovery and money in your pocket. Now that truck goes out and picks up its wet route, and it's based on the wet characteristics of the source, like restaurants and golf courses and food waste processors and things. And there may be some other stuff too, hospitality and such. Even a construction site could be put into the wet load because it's mostly wood. But rerouting is based on the supposed wet characteristic of the sources, and it's mostly organic, often greater than 75%. Low to moderate contamination. In other words, organics, just like dry material can be contaminated with wet stuff, the uh, the organic material could be contaminated with too much plastic, too much metal, too much glass, too much other things. So there's contamination that you can eliminate. That means this material might be highly compostable, might be really acceptable for anaerobic digestion. And so there's less effort to sort out the non-organic contaminants. So you can see, you know, moderate separation is needed, but the same truck can be used, but you're going to come back with something that's going to be more highly recoverable. This is where haulers can actually monetize sustainability and conservation. Well, roll-off loads have their own characteristics too. They're often like I say, they're single source, always single source. They're often consistent material. Take a look at this load that somebody dropped. It was nothing but cardboard and stuff. Different types of paper, but very recoverable. Sometimes things are compacted, sometimes they're not. The bin that's shown here is a non-compacted bin. And invariably, it's very dry, highly recoverable. And anywhere about 10 to 15% of total loads are typically roll-off type boxes. I talked about self-haul loads, and self-haul loads are often single source. A lot of times they're whole goods and products like roofing tear-outs, cleanup jobs, remodels, move out, people getting rid of things, they're remodeling their office and they got to get rid of desks and stuff. And a lot of this stuff is highly reusable, mostly dry, up to 30% of all traffic, but it's only like about up to 15% by weight because there's small loads. And 1-800-GOT-JUNK is very typical for this type of operation. And in fact, here, this gal that's got her junk removal service, you can see is mostly dry material there that she's got, boxes and wood and dry vegetation. Something's in that plastic bag, I don't know what, but it's just all basically junk that gets picked up. And usually there's a minimum dump charge. So regardless if you bring in a quarter of a ton or half a ton, you're going to pay some minimum dump charge. So these are very lucrative for MRFs and transfer stations. The whole point of this particular presentation is that we got to reduce the complex to the simple. You look at this city, it looks complicated. It is complicated, but it's not so complicated because we can use the 9 sources and their generation characteristics to develop very doable 3R programs. Just remember, recycling is the last thing to do. And you got to start upstream with reduce, redesign, and refuse. Then you can focus on repair and recycling. Compost, and I put composting and things like that in recycling. It's treatment because once you generate it, you got to do something with it. And it's always more costly, and generally landfilling is like the cheapest thing around. So composting and recycling is going to cost more, but it's all disposal. And folks don't get that. They think that disposal only refers to landfilling. No. So composting, landfilling, and recycling should be able to receive any of the fees that are part of of the collection network. That's where we can get the circular accountability in there and properly cost out the cost of extraction, because it costs money to make things new from virgin material, right? To cut down a tree, it costs money. To mine, it costs money. Well, to extract fiber from office buildings costs money. That's an extraction cost. There, maybe the material that you extract has a greater value than than the cost. But so often that's not the case with recycling and repair. It's going to cost more to extract it than the material is actually worth. So that's why that those extraction costs should be covered by our waste management systems. I borrowed the desk guide prepared by the firm Waste Management to show you how they tend to train their dispatchers and salespeople and things of that nature. Um, they have a classification of different types of sources, very similar to what I use. And they have building types, and you can see commercial buildings, office, department store, shopping centers, supermarkets, restaurants, drugstores, banks, and you have quantities of waste generated. So this is a very useful type of chart. It's a guideline, only guidelines, and the volume is derived from nationwide averages, so using varying weights per cubic yard, but it's really useful. So you may want to use this if you're doing very similar type of work. Again, warehouses and factories varies with the type of activity. I mentioned that factories, services and industrial are highly variable, but generally whatever is the activity, that's what waste is being generated. If it's a paper mill, well, they're generating paper waste. If it's a rubber manufacturer, they're generating rubber. If it's a textile manufacturer, they're generating textiles. So it goes on and on and on. It's just what they do determines what they waste. And you can see here a lot of different emission factors, which I think can be very, very helpful in terms of creating, you might say, a waste profile. So let's take a look at some of the containers that people use in roll-off. They range anywhere from a smaller 8-yard container. You can see it's like 10 foot long, 3.5 foot high, and 8 foot wide, all the way up to a 40-yard container, which is almost 24 feet long and 8.5 feet high. You notice that most of the containers are like 8 feet wide, and that's a sort of an industry standard. The length of it doesn't really matter. The height of it doesn't really matter. Um, the 15-yard container is only 2 foot high, and they tend to call that low. They call it a low boy because it's only 2 feet high. It's easier to load stuff, especially if it's really heavy, into that container rather than try to lift something over 8.5 feet. And a lot of the compactors are going to be 30-yard and 40-yard containers. The little bins that you see in many businesses, we often refer to them as dumpsters. They range from very small, 1 cubic yard, all the way up to maybe 6, and I've seen some as big as 9. But you get that size, it becomes very, very difficult to pick up. Now, the thing that's important here, you see that they have different heights and they have different depth, but they all are the same width, 82 inches wide, because that, for a front loader, is the fork. That's how far the forks are. The forks could be, like brought in closer to each other, but generally people don't want to do that. Haulers don't want to do that. So they buy these containers so that the forks fit perfectly into those slots around the side. And the 3-yard container is the most commonly used, and generally one of these is picked up once per week, and that's the most common level of frequency of service. And for these things, 1 cubic yard is the equivalent of two 100-gallon carts. So a 3-yard is just like 6 100-gallon carts. For the typical single-family residence carts, and sometimes these carts can also be used in apartments as well, although you have to have a lot more because remember, the largest size, you can get one bin and you can have the equivalent of 6 of them, so it might be better. But cart sizes generally go in these types of, with some little bit of variability. 32 could be 35, 64 could be, I don't know, 65, 96 could be 100 or 90 gallon, they can vary. And they all have a very similar type of construction, because you got these forks, and the forks on the side loaders will fit, and you want to lift it up. And if they were just strictly straight and didn't have that kind of like construction, they might slip through the crack, slip through the slip through the system, and then they'd spill, and there'd be a mess. But in any event, you can see that the person I have here is 5'4", and she's got a compost container there, not a compost container, but an organics recycling container, small thing, maybe 20 gallons or less. And then you have like, you can say big dog size, medium dog size, small dog size, and micro size dog sized. They all have, wheels to roll them around, and handles for people to move them around. Not too much more, but I did want to say that change is inevitable. We can always expect change to occur, and our methods and analytics need to change and adapt as well. So what we did yesterday is not necessarily what we need to do tomorrow. As you can see, we had folks picking up trash using horses. And down below at the bottom there, like a lot of folks, especially gals, are picking through trash at a local trash site. And there would be a lot of them in a community where people could go out and pick through stuff. And these were dustbin pickers or scavengers that would pick up stuff. But I remember back in the 50s, it's like this is an old type of cartoon here, but at some point, garbage disposals were installed. And garbage disposals, prior to that, you had to put your garbage out at the curb. And so that a lot of times that got picked up and got fed to the pigs. Now, though, is like garbage? What garbage? Well, that actually is probably going to see a little bit more usage again, because that's a way for apartments, which often invariably have garbage disposals, can handle a lot of their organics, is by putting it down the drain, because that can go down to the wastewater treatment plant, where now they can recover that and turn it into, through anaerobic digestion, into reusable gas. So that's an opportunity. Interestingly, from the early 1900s until 1960, the most successful high technology system existed through most of the eastern seaboard of the U.S. It was called the garbage reduction plant. And in 1959, Philadelphia closed its reduction plant, and it was the last one in the country. And it basically turned organic waste into fats, greases, and oils. But when all the organics kind of like disappeared from the waste stream, people were putting them into the garbage disposals. It just became, nobody was separating their organics anymore, so it lost a lot of the value of what it could do, and these plants these reduction plants would actually take organics and turn them into feedstocks that, for example, were used in the manufacture of women's lipstick. So it was really interesting. So like I'm saying, trends are really important to understand. And you can see I got 1905, 1960, and 2010, so that's a pretty good spread. And in 1905, most people, burnt their own trash and then put it into a small container, and there was very little food and yard waste and very little products and packaging. I mean, it was just like mostly just burn stuff and create ash. And that ash was taken out to the ocean and dumped in the ocean or just spread on the land. And what food was fed to the pigs. But by 1960, products and packaging were outstripping and any other type of waste. Still, food was continuing to increase, food and yard waste, especially as we developed in the 1960s a lot of housing tracts in which everybody had manicured lawns. You notice that ash disappeared because we got rid of all this backyard incinerators, and a lot of incineration disappeared from the our country. In 2010, we see that products and packaging far outstrips everything else, but again, food waste is still growing. And textiles, which are part of food waste, or can be part of the red bar, are the fastest growing category of waste, followed closely by electronics. So the idea here is that our waste systems have to kind of like we have to be cognizant of what the trends are and be able to meet the need and demand. Reported diversion by jurisdictions. Oh my gosh, you have to beware of fake recycling rates. Even Los Angeles and San Francisco report high diversion rates, and they pat themselves on the back for high diversion rates. Yet if you look at Germany and the US as a whole and Berlin, you can see that the green area, which is the recycling, and composting diversion, actually is very comparable between San Francisco and the US and other places around the world. But there's this huge slug of other diversion, inert reuse, biosolids. This stuff is not really recycling, but it gets called recycling just so the community can say that they're doing a good job. No, it is really stuff that was already done. They just count it as recycling. LA, for example, reports 70% diversion, yet that 70%, it increased in one day from 10% to 70% simply due to a study that the state approved that identified pre-existing diversion of concrete and land spreading of biosolids. The former, that's the concrete, is very heavy and nationally is diverted at 75% as ADC road base and mining infill. So it's like, that's not really doing the job. That's just like taking a number, throwing it in there, and they didn't do anything about the trash. If you compare the black part of those charts, take a look at Berlin, Germany, and the US. They're either less or equivalent to San Francisco. San Francisco did not decrease its wasting. It just increased what it was counting. And that's just like, what do they say? Figures don't lie, but liars figure. Okay, so beware this type of counting. Well, thank you very much for sitting through this very long video. I want you to be sure to catch the Dystopia ride at Disneyland. You might check out Jeff Gillette, and he's kind of took a look at a lot of things that he saw, and he actually came to Disneyland. This is like many years ago from Detroit. I guess he was so excited and he was so like alarmed at what he found at Disneyland. And it's not real life, but it's kind of manufactured of the idealistic way that we want maybe to look at things. So cars, I mean, my gosh, everybody's in their own little car and there's traffic jams and people bumping each other and stuff. That's why I called it, instead of autotopia, dystopia. So beware the illusion of unlimited gross national product. That's kind of my point here. All right, so talk to you next time. All right, ciao.